Again, welcome to Principles of Epidemiology. In these lectures, we're going to cover the comparing disease frequencies. This is part 2 of our lecture. Again, this is lecture number 3. So our main objective, again, we are going to define, calculate, and also interpret the relative measures of association. Also, we're going to discuss the differences between absolute and also relative measures and when they are most appropriate. So here again, we're going to do a recap here, start with the definition and also the goals of epidemiologists. According to our previous lectures, we said the definition of epidemiology is the study of the distribution and determinants of disease frequency in human populations and the application of these studies to control health problems. So again, epidemiology is a branch of a public health studies field. Which is again deal with a community health. So the main goals of epidemiology is to determine the extent of disease in a population. If there's any outbreak, maybe we have a specific disease that normally occurs in a population of 2%. All of a study, we have over 50% of the population having that disease, or even 20%. This will be an outbreak. This can be involve epidemiologists to find out the determinants of the disease frequency and how the disease is distributed among the population. That's the population characteristics. Are more female getting the disease than male, or are more younger population getting the disease than the older population? So we need to determine the extent of disease in the population and also identify the patterns and trends of disease occurrence, such as person, place, and time. This is normally we call the descriptive epidemiology. And we're going to cover this topic again in the future. Also, we are going to identify the causes of disease. And also this is called the analytic epidemiologies. So we have two branches of epidemiologies, or two parts of epidemiology: the descriptive epidemiologies and also the analytic epidemiology. Also, the last goal is the evaluate the effectiveness of interventions. Example, if we have any preventions program or treatment program. Example of a prevention program would be, let's say, HIV virus. One of the prevention program would be we practice a safe intercourse, or other diseases may have a different program. Or if there's any treatment, again, we go with it. So association versus causation. First, we start with counting. Counting may lead to the association. Association means we want to find out if there's any relationship between the risk factors and the outcome or the disease. So here we just want to, association means finding the relationship. Then the final stage, which is our main goal as an epidemiologist, is to find out the causes of the disease or the outcome. So that's the causation. Always there should be an association before causation. Because, for example, we cannot say a risk factor of A causes the outcome of B, but there's no association or relationship between A and B. There must be an association before causation. So what we mean by association here, we say an identifiable relationship between the exposure, in this case can be the risk factors, and then the disease or the outcome. Comparisons of risk or rate yields an association. And that's our main goal of these lectures. Also implies that exposure might cause, again, a disease. So exposures associated with differences in disease risk. And these are called the risk factors or preventive factors. Also, unobserved associations do not necessarily represent a cause and effect relationship. So as epidemiologists normally studies Studies do not determine the cause. Again, normally epidemiologic studies do not determine the cause of a disease in a given individual. As epidemiologists, our main goal is to find out if there's any association or relationship between a given exposure and also the disease frequency in the population. So epidemiologists will infer the causation. Again, the key word is infer. We'll make a decision on the causation, again, based upon an existing relationship or association between the exposure and the disease, and if there's any several other factors. So the causal inference is a judgment. And again, we will talk about the Hill's guideline for causal inference later in the course. So I think that's the key word here. As an epidemiologist, our main goal is to find out if there's any relationship or association between, again, a risk factors and a disease or the outcome. A very simple example, as an epidemiologist, I want to find out if there's a relationship between cigarette smoking and lung cancer. I'm not going to go direct and do a studies to find out if a cigarette causes lung cancer. But as we mentioned earlier, if there's a relationship or association between two variables, there's a possibility that there will be a causation. And also there's a possibility that there will be no causation, because we know confounding variable may be one of the factors or modification effects. So let's get right into another measure of association. Again, part one, we learned about some few measures of association, both the absolute and relative. So we do the absolute, for example, the relative measurement and also the absolute measurements, where we discuss about the difference measures and also the ratio. Relative will be ratio measurements. So here they say, assuming a causal association between exposure and disease, the proportion of disease in the total population that can be attributed to exposure, or assuming a causal association between exposure and disease, the proportion of disease in the total population that will have been prevented if the exposure had not occurred. So here we have, as we said earlier, we have the absolute and relative measures. Absolute measure go with the difference measures. So here we can have RT minus RU. And the answer percentage will be times 100. So RT will stand for the risk for the whole total population. And RU will be the risk for the unexposed. So here we say where R equal to P and CI, or it can be P again is the prevalence. So the risk here, we can say whether it's a rate or, so it can be a prevalence or confidence in, the cumulative incidence or IR. So we also have the ratio measures. We can see that the ratio measures, we have a numerator and denominator. It's again a ratio. So here we have PE. PE will be the population that is exposed. Then RR can be whether the prevalence, risk ratio, or incidence rates, etc. So we have RR minus 1 divided by PE, RR minus 1 plus 1. So again, we're going to see an example soon. So here we say using the RR, we should calculate the proportion of MI. Again, MI is our myocardial infarction. So that will be our disease. Cases in the total study population that would have been avoided if the women did not have hypertension. Again, we saw this example in our previous lectures, which was the part 1. And we had cases where we have women with hypertension, 13,000 422. They are total 13,422. And we said that 117 out of the 13,422 have MI, myocardial infarction. So that means if we subtract 117 from 13,422, we may have 13,305. So those are the women that doesn't have the MI. So if no MI means, again, they are exposed. Hypertension will be our risk factors here, or they're exposed. So we have women that are exposed to hypertension, or whatever the risk factor is, in this case, hypertension. But 13,305 doesn't have the disease. 117 have it. Then we have women that are not exposed to the risk factors, which again is the hypertension. Here we have 106,541. And out of the 106,541, they don't have no hypertension, but 125 have the problem, the disease, MI. And when we subtract 125 from 106,541, we have 106,416, which means they are not exposed and also they don't have the MI. So the total MI will be 242. That's 117 plus 125. And the whole total population for both who are exposed and those who are not exposed, the total population is 119,963. Then the total population that they don't have the MI is 119,721. So our goal here is to find the population attributable proportion, which will be PE RR minus 1 over PE RR minus 1 plus 1 times 100. Again, the 100 is somewhere around here, but it's supposed to be times 100. So the answer we get will be in percentage. So how do we find PE? PE stands for the proportion exposed. So we have to go to our data. Exposed here is the women with their hypertension. So the proportion will be those who are exposed divided by the total population. So those total exposed is 13,422, and the total population is 119,963. So here we have the calculation: 13,422 divided by 119,963, and the answer is 0.112. So now we know the PE. So next we can find our population attributable proportion. Again, in our previous lectures, part 1, we found the relative risk, or sometimes we use the term risk ratio, RR. And also we have the PE now, so we can plug in the value. Remember, relative risk is for the relative measures. And we have the cumulative incidence. Again, we have the two proportion we divide. So when we finish, the answer here was 41.9%. So this will tell us that if the association between the hypertension and MI is causal, then 41.9% of MI among women in the nurses' health study will have been avoided if they had normal blood pressure instead of, again, hypertension. Again, the question is in our part 1 studies during the 10-year study period. In this question, we had a total women of 13,422 that have hypertension, and 117 have MI. Then we have 106,541 women. They don't have no hypertension, but 125 have MI. So the goal here, and then we had a follow-up for 10 years. Again, that's for 10 years period. So the goal here, we want to know if there's any relationship or association between MI and hypertension based on the data we collected. Again, we found the RR in our previous lectures, part 1. So in order to understand this concept, again, you have to go through the part 1 video first. So we have some practice question here, true or false. Here we say a study was conducted that collected interview data and brought samples from 8,000 people. The investigators found that 11% of people classified as heavy drinkers of alcohol were involved in home accident over a 3-month period. This means that there was an association between heavy drinking and home accidents in these studies. It is very difficult to say that, so the answer will be false. The reason why, because again, based on the question here, again, data was collected, but the investigators found that only 11% of people classified as heavy drinkers of alcohol were involved in a home accident over a 3-month period. Again, the percentage, only 11%. Then this means that there was an association between heavy drinking and home accident in these studies. The answer will be false. We need more data or other factors because 11% was very small. Now, the next question says, study was conducted comparing the risk of hip fracture in women according to body mass index over a 10-year period. Now, women with high body mass index had a risk of 0.10. Women with a normal BMI had a risk of 0.15. And women with a low BMI had a risk of 0.40. Now, the question says, what was the RD comparing women with low BMI to women with normal BMI over 10 years period? RD stands for the risk difference. So what was the risk difference comparing the two? Here again, we are doing comparing frequencies of different groups, frequency of disease in different groups. So here we have 2 groups, actually 3 groups. But here we're going to compare women with low BMI to women with normal BMI. So 2 groups. So based on this question, the answer will be 0.25. Again, in order to solve this problem, we have to go through the lecture number 1. We need to find the risk, the attributable risk for BMI women with the normal and also with the low BMI and normal BMI. We have the data here. So when we find the cumulative incidence of both, we find the difference of it. So again, RD, we solved that problem in our previous lectures. We find the cumulative incidence for both low BMI women group and normal BMI women group. There, again, we find the difference. So another study is a study was conducted comparing the risk of hip fracture in women according to the body mass index over a 10-year period. Again, the same question we have. Women with high body mass index had a risk of 0.10, women with normal. And so here we have 2 groups again, the same question. But this time, we say what was the relative difference, risk difference, comparing women with high BMI to women with normal BMI. So again, we have the data, so we have to find the cumulative incidence for high BMI for women and also the normal BMI for women. Then we find the difference. This is again risk difference. So if we do that, the answer will be negative 0.05. First, high BMI will be those who are exposed to BMI. So remember in part 1, always to be those exposed minus those who are not exposed, cumulative incidence for exposed and not exposed. Or it can be prevalence, also prevalence of exposed minus unexposed. So a negative answer means the risk factor is very low, because those who are exposed is less than those who are not exposed. They have less disease than those who are. That's why the answer, always again, risk difference. I didn't want to go through this because it's in our part 1 lecture of this topic. It's the same topic. To break it into 2 parts because of the time. So the risk difference, it can be either prevalence or cumulative incidence of exposed minus prevalence or cumulative incidence of not exposed. So if the answer is negative, it means those who are not exposed, they have more cases than those who are exposed. So the risk factor doesn't have much. It's a very weak association between the risk factors or the exposed with the disease. So the summary of BMI and hip fracture result, we saw the low versus normal, it was 0.40, again minus 0.15. So we compare again, compared to women, since it's positive 0.25, so it's 25%. So which means the exposed or the risk factors have effect on the disease. So comparing to women with normal BMI, women with low BMI have 25% higher risk, because normal is okay. Normal means you are not exposed, but whether it's low or high, then you are exposed. That can have effect on the outcome. So we say 25% higher risk of hip fractures over 10 years. Then the second question, when we are comparing the high with the normal, we saw the answer is negative now. So less 5%. So that means the high BMI is better. Compared to women with normal BMI, women with high BMI have 5% lower risk, lower because it's negative, of hip fractures over 10 years period. So again, based on the question, we have 3 groups of women: low BMI, high BMI, and normal BMI. But we break the question into 2, comparing. Normal is okay. Normal means we are not exposed. That's what it is. But low and high, then here we have exposed or the risk factors. So we want to see if it had to have anything to do with the hip fractures based on your BMI. So a study was conducted comparing the risk of hip fractures in a women according to the body mass index over a 10-year period. Women with high body mass index had a risk of 0.10. Women with normal had a risk of 0.15. And the women with lower, again, the same question, 3 different groups, but we are going to compare 2 groups at a time, compare the normal with high, the normal with the low. As we said earlier, normal means you are not exposed. High or low means you are exposed. But this time we are doing relative measures, relative association measures. So previous 2 questions, we did the risk difference, and we compared the normal with low and also the normal with high. Now we are doing the relative risk. This is relative. So we're going to start with comparing the low BMI to normal BMI. So this means we're going to divide the exposed by not exposed. Not exposed will be the normal result. And here the answer will be 2.67. Now let's look at the data. Why is it 2.67, which means it's high? So if we expose body mass index at the risk of 0.1, we are doing the high, normal, we're comparing the low. So had the risk of women with the low is okay, so very high. Just by looking at it, 0.40. And normal is 0.15. And always we divide the exposed, let's say cumulative incidence of exposed divided by cumulative incidence of unexposed. So we can see the risk factors for it's 2.67. The reason why, because again, the risk factor for low is 0.40 and normal is only 0.15. Relative means ratio, relative ratio. So we divide exposed by not exposed. Then we go to the second part. This time also we are going to compare the normal with high. So we look at the high risk. The high risk again is 10. So you can see that high risk is 10, and then the normal risk is 0.15. So it will be more than, less than 1, because 0.15 is greater than 10. So this time our answer will be lesser, which is 0.67. So relative risk, again, the previous two questions, when you are doing the risk difference, you are looking for the absolute. So you find the difference of the cumulative incidence or prevalence or whatever measurement you have. You find the difference of the exposed minus unexposed. Now, when you are doing RR, which is the relative risk, we always divide the exposed by not exposed. So if the risk of exposed is higher than not exposed, then we're expecting to get a value more than 1, which means the risk is have effect, more stronger association with the outcome. But this second question now, we find out that the high BMI have only 0.10, but the normal have 0.15. So 0.10, even 0.10 divided 0.15 will give me a value less than 1. So with this, we are going to interpret it, but if we have a result less than 1, it means the risk factor has a weak association with the outcome. So this is the best interpretation for error. Women using the HRT had a 0.50 times the rate of corona disease compared with women not using HRT. And women using HRT had a 0.50 times corona disease with women not using HRT. And women using HRT had a 0.5 times less. Less means, again, our value was lesser than 1, the ratio. So the answer here, again, this is a different question. It's a study evaluating the rate of corona disease among women using hormone replacement therapy compared with women not using HRT, yielded RR equal to 0. So here we find the relative risk to be this. But when we look at the question, they say the study evaluate the rate of corona disease among women using HRT compared with the women not using HRT. So our risk factors here will be the exposed will be our HRT studies and therapy, HRT. So if it's 0.50, it means when using the HRT, we had 0.50 times the rate of corona disease compared with women not using it. Because always the exposed divided by unexposed. Also a question here, study evaluating the rate of corona disease among women who have high cholesterol level compared with women who have normal level, yielded RR equal to. So here, the study is what? Exposed to be high cholesterol level. If you have a normal cholesterol level, that's good. You are not exposed to cholesterol, that's normal. But when the answer is 1.8, it means almost twice. So those with a high cholesterol level, they have twice of the chance of getting the corona disease. So in this case, our answer will be A, which said women with high cholesterol levels had almost twice or 1.8 times the rate of corona disease comparing to women with normal levels. Again, the main examples of this question is how to interpret the relative risk or even the risk difference. So risk difference, when we are going to interpret it, we'll say more or less, because risk difference is something minus something, exposed cumulative incidence minus unexposed cumulative. So we're going to get the actual value. And whatever value we get, we will say whether it's more if you're exposed. If the answer is less, that means it's negative. If I divide the exposed value minus the unexposed value and I get negative, it means it's less. So we have another question here. Here we say a relative risk or RR equal to 1.75 was obtained from a study examining the risk of asthma among children. So our exposed here will be asthma, or the risk factors is asthma among children who live less than or equal to 0.5 miles from an urban bus route, comparing to children who live greater than 0.5 miles from an urban bus route. So here they say, which of the following does not accurately describe this relative risk? Again, here our exposed will be those who live closer, and it's asthma, which is less than or equal to 0.5 miles. So when we look at the first answer, they say compare with children who live further away. So we are compared with children who live further away, which is over 0.5 miles. Children who live less than or equal to 0.5 miles from urban bus route were 1.7 times as likely to develop asthma. And this answer is almost opposite. So, but when we go to the correct answer, compare with children who live further away. Children who live less than or equal to 0.5 miles from an urban bus ride have had 175% increase risk of developing asthma because it's 1.75. So that would be our answer. So another question we have, RR equal to 0.80 was obtained from study examining the risk of asthma among children who took vitamins every day compared with children who did not take vitamins every day. So taking vitamin will be our exposed. Now we can see the value is 0.8, which means it's less than 100%, which the difference will be 0.20. So we say again, comparing with children who did not take vitamin, children who took vitamin were 0.80 times less likely to develop asthma. And that's true because 0.80 was obtained from study examining the risk of among children who took vitamin every day, comparing with those who don't take it. So it's less. We have another question. Follow-up study was conducted on the risk of death among elderly men and women in relation to their recent influenza vaccination history. Over a 1-year follow-up period, there were 243 deaths among 77,738 vaccinated subjects and 1,261 deaths among 62,217 unvaccinated subjects. Now, the best way to solve this problem is to come up with a 2-by-2 table, because we can see the data, those who are vaccinated and those who are not vaccinated. So vaccinated will be exposed, unvaccinated will be unexposed. So we are going to put this data into a 2-by-2 table. Then we calculate the risk of mortality in a vaccinated and also unvaccinated group. Then we can interpret the mortality risk difference, compare vaccinated. Then we can also find the risk ratio. So here we want to, step 3, we are going to calculate the absolute measurement of the association between vaccinated people and unvaccinated. Then in step 4, we are going to find the relative measures association between those who vaccinated and unvaccinated. So step 1, we get the table together. That's the data here. Those who are vaccinated, those who died were 943. The total was given to us to be 77738. So if I subtract 943 from 77738, which is right here, I'll get 76,795, which means those who are vaccinated and they did not die is 76,795. The same thing, we have the data for those who are not vaccinated. The total for those who are not vaccinated is 62,217, which is right here. And from the question, 1,361 died, which is right here. So we subtract 1,361 from 62,217. We get 60,856. So now we have our 2x2 table, all the data we need. The total population is given. Total who died, we were able to add all together. Total who did not die, we had all together also, which we have these three total values. So now we finish with step one. Now we want to find, first of all, we do the absolute measurement of the association. So we look for the cumulative incidence for those who are exposed, vaccinated. So it will be 943 divided by 77738, the total vaccinated and those who have the problem. The same to find the cumulative incidence for those who are not vaccinated. And that gave us 1361 divided by 62217, the total not vaccinated and those who die. And the result is 0.0121 for vaccinated and 0.0219 for not vaccinated. So with these two values now, we can find the risk difference, which is the step 3. Risk difference again gives us the absolute measure of the association. So it will be the difference between those who are exposed and those who are not exposed, the cumulative incidence. And the answer here was, again, we find the difference and we change it to a whole number. So the answer will be 0.00098. So later it will be 98 by 10,000, which means 98 deaths per 10,000 population. Now, next, we find the relative risk. So relative risk is the same concept. We divide the cumulative incidence for exposed, which is vaccinated, divided by not vaccinated cumulative incidence. So all we need is the cumulative incidence for both exposed and not exposed. If we find the difference of the two, we get risk difference to measure the absolute measure for association. When we find the relative risk, we are doing the relative measurement of the association. Here we get our answer to be 0.55. 0.55. So now we can also interpret the answer. So here we are going to interpret. The risk difference gives us negative 98 by 10,000. So what we mean here is that subject with recent flu vaccination had 98 fewer deaths per 10,000, again 10,000, because the answer was negative. Why is it negative? Because we can see that the cumulative incidence for vaccinated is less than the cumulative incidence for not vaccinated. 0.0121, 0.0219. So the answer will be 0.0008998. So that's why we say less, because it's negative. Then here also we have less than 1. So the same concept. Subject with recent flu vaccination have 0.55 times the risk of death, or 45% reduced risk of death over the following year as compared to subject without the recent flu vaccinations. So again, that will be the conclusion of our lectures. Again, this last example really cover everything that we learn in both chapter 1 and part 1 and part 2 of these lectures. Again, this is the part 2 lectures of comparing disease frequency. We said from part 1 that comparing disease frequency, the main thing is we want to find association. Again, the main objective of epidemiologists is not to find the causation between exposure and the outcome or disease straightforward. It's rather to find the association first. We can find the association if we have 2 or more groups by comparing the unexposed with the exposed. The very good example was the one we talk about, the body mass index. We have 3 groups. but we want to know if there's a relationship between the body mass index with the normal body. Normal body mass index means they are not exposed. But when you have low or high body mass index, then you are exposed to it. So we take the normal compared with the low, we take the normal compared with the high. Then we can do both our absolute measurement of the relationship between those two, or we can do a relative measurement between the two. So again, wish everybody the best and thank you.